Hi everyone. So in the last video we have covered till the first question, that is the largest element in an array and the second largest, but I actually forgot to tell about the time complexity and the space complexity about those both codes. So let's discuss very quickly the time complexity and the space complexity of the very first two questions. So the first question was that the largest element in an array. The time complexity here it's O of n. So like as we go in the series, you will come across different time complexity, and if you follow the series you will definitely understand. And this first one is today's complexity is very basic. Since we have used one for loop, so we are having a time complexity of O of n, okay, big O of n, okay. And the space complexity here remain constant because we are not in using any, and it's because of what it's just O of 1, that is constant of course, because it's already getting in one pass, and also there we are not using any other data structure here like sets or anything else here. It's only using a single for loop, so it's only O of big of n, and the space complexity is similarly O of 1, right? And for the second question, for the better approach, the time complexity is big of n plus big of n, because we are using two for loops here. One is here and the other one is here, right? Due to which we are having big of 2n. It will be better if you tell this to the interviewer, that is big of 2n, but which is, of course, don't forget to remove the constant, because we have to remove the constant every time or the other. So the final result will be big of n. Constant 2 is the constant here, 2 is the constant here, and it will be removed, of course, obviously. And the space complexity is again big of 1, that is constant, because it's again no structure or no nothing, any other time sales or anything other than this are not used, only we have done using two for loops, right? So don't forget to tell, it will be nice if you say this, big of 2n, which is already is equals to big of n. And for the, of course, for the time complexity of the optimal approach, which is the best one, we have the time complexities that, of course, it should be the best, so we have big of n. And space complexity is also the best, so we have the big of 1, because we are using a, now we can, I think till now you can understand very clearly that we are using a single for loop, therefore the time complexity will be big of 1, right? Okay, so now let's move to today's next two question. In this one video we'll be covering up the check if the array is sorted, and remove duplicates from sorted arrays. If you have any queries related to the time complexity and space complexity, do let me know in the comment section below. And now let's come up with this two question. So we have check. Okay, so now let's go with the first question of today, that is check if the array is sorted. Okay, so sorting basically means it can be in decreasing order, or as well as in increasing order. In the question or the interval, in the question it will be actually given in what form you have to sort, whether in decreasing order or in non-decreasing or in increasing or in non-decreasing. Okay, so here in the question it's given that the sorting it should be done in non-decreasing order, that is in increasing order, right? Like small to big. So here we can see 10, 20, 30. It's in increasing order, that is not decreasing. So it will return 1. The question says that if the given question is in increasing, that is non-decreasing order, then you have to return 1. That is true. In the DSA or computer science coding, we actually use true as 1. We represent true as 1 and false as 0. I hope everyone knows this till now. And for here, we can say it's not in, increasing order. Therefore, it should be in increasing order as 30, 40, but it's not. It's 90 is coming at first, so we have to return false here, right? So let's look at the code. This question doesn't have any, like brute force type thing. So if you directly solve the question, we just have to check it, right? So what we are gonna do, we are using a for loop, okay? So after using the for loop, we are initializing I as 0, and then n minus 1 and I plus plus. And then we are checking. See, I will tell you the logic behind writing n minus 1 here, because I know many of you won't understand in the first go. So we are checking if array I is less than is equals to the I plus 1. Since the next element should be larger, so this will be the first element, of course. So here I have written a bit. If I is equals to if I is equals to 2, okay, given. Okay, if I is equals to 2, then the next element will be of course 2 plus 1, right? That is 3. And if I is just 0, then the next element will be of course I plus 1, right? So here that's why we have taken I plus 1 to denote the next element. Okay, we are denoting the next element as I plus 1. So if this previous element is array of I, the next element will be I plus 1. So here the condition should be that if array of the first element is less than is equals to next element, that is I plus 1, then return true. Okay, if it's not, then return false, that is 0. Okay, and the logic behind writing n minus 1 is very simple. See, suppose we are taking n as 10, right? Since we are initialing I as 0, so we just have 10 elements with us, but 0 is adding a one extra space here, right? That is 0. Okay, 0 is already adding an extra space here, and we are having n as 10. But if you count, here are total 11 elements, but that doesn't actually go because we are having n is equals to 0 here, right? Therefore we have to remove this 10, or we can say n minus 1, like n should be one less, that is n minus 1. That's why we have taken n minus 1. Otherwise, when n will come to 9, it will go as 9 plus 1 to check the next element, and it will go out of bound, right? Which will give a runtime error, of course. That's why we have taken n minus 1 to avoid this type of errors, which can give us runtime error, anything else also. So that's basically the whole code is all about. If you have any question, you can definitely comments below, and let's look in the second question of today. Okay, and let's discuss the time complexity and the space complexity. Since here we have used only single one for loop, so the time complexity will be of big of n, and the space complexity once again big of 1, that is constant. So let's go over the fourth question. That is the remove duplicates from the sorted array. Let me tell this all the things. I don't know why lit code have written just to make us scared, but it's very simple. Remove duplicates from a sorted array. The question itself says that the array is already sorted, okay, in non-decreasing order. That's in increasing order, right? We can already see 1, then 2, 0, 1, 2, 3, 4, and we have to just remove the duplicates. That means you have to just count. This question, we have to just keep the unique elements first, and after that we have to give the return the number of unique elements present in that array. Okay, just you have to return that. Here we have two unique elements, that is 1 and 2. So you have to count how many unique elements are here and return that. That is 2. Similarly, here we have 0, 1, 2, 3 and 4. Total we have 5 unique elements. So the output will be 5. Okay, don't have to look for this. We don't have to return this. Okay, we don't have to return this much. We don't have to return. We just have to return the number of unique elements present in that array, and you just have to return that. Okay, and for that, what we can do? See, of course, if you know the set in vector, we have learned, right? Set is actually things that actually store the unique elements in a vector. STL vector where I was learning, I can still remember. Set at the a kind of thing. I don't know what to say, but yeah, set basically stores the unique elements in an array or anything. It can be. So here we can use set, right? The brute force can be done by set, of course. Okay, so you just initialize a set. After that, you use a for loop to iterate through that, and then check it how many unique elements are present. And since set only take unique element and just put it one by one, but the brute force is not our best solution. Our motive is to find the optimal solution, which I already have here with me. So this approach is basically a two-pointer approach. Okay, so here we have taken j is equals to 1 because every time there will be 1 or anything will be present. 1 or 2, a single element will be of course present here, right? So we have taken j is equals to 1, and now we are initializing j is equals to 0 because we will check, the second element. So previously we will already, since here we have two elements, so we are using a two pointer. So I will be here, J will have two, so that when it comes here, it doesn't lose the count of this one. So keep the count of this previous one, we have taken J is equals to 1. So that while it counts to a single one, and then it also add 1 plus 1, like the previous count of the 1, because you have to always remember, you have to just return the output of the number of unique element present here. So we have used a for loops here, that's in I is equals to 0 and again till -1, so that we have seen, I have in the previous question I have already explained why I have written -1, and we have written nums dot size. This basically gives how many, it's the number of elements present in that array. Nums dot size return the number of elements present in that array, that's written in vector here, initialized already from previously. So for I is equals to 0 and I less than nums dot size, that's -1, and then I plus plus, and then we are checking whether the current element is equals to the next element. For next element, of course, I have already taught in the this question why it's I plus 1. The next element we will be denoting as I plus 1, right? So if it's not equals to that, if 1 is not equals to 2, then what we will do, we will initialize that this element to our J, okay, and J will get a new number, okay, and the count of J will be increasing. So J plus plus, we will just initialize this value, the new thing, unique element which we have gotten in J, right? This client basically says that as soon as we get a new element, we will put the value of that element in this J, and J plus plus, the count of J will increase as 1 by 1, and then we will return J, and this is the solution basically. And if we discuss the time complexity, then the time complexity is basically big of n. Once again, we have used one single for loop, and similarly the space complexity will be also big of 1, that is constant, because it's already done by one pass, and no more other test structure is also used here. So this is the solution for this two question. I hope you liked it. If you did, then do give a like, share, and yeah, do comment below if you have any queries. Thank you so much for watching.